If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So today again we will be solving 5 questions starting from question number 26 to question number 30. Okay, then let's try to solve all these questions. Okay, in question number 26, a 50 kilowatt DC shunt motor is loaded to draw a rated armature current. It will draw always armature current rated. It is fixed. Okay, at any given speed. And driven, number 1, at half the rated speed by armature voltage controlled. Second one, at 1.5 times the rated speed by field control. The respective output powers delivered by the motor are approximately. Okay, in the first case, if you see, it is half the rated speed by armature voltage control. Okay, so power is equal to torque into omega. That we know. Now torque is directly proportional to phi into Ia. Because Ia is fixed here, for first case I am considering, Ia is fixed for first and second in both cases because it is supposed to draw the rated armature current, so it is fixed. And in the first case you are using armature voltage control, that means phi is also fixed, field is also you are not changing. In the second case you are changing field, but in first case it is fixed, that means torque is fixed, so this is fixed. So if this is fixed, you are reducing the speed by half. If you are reducing the speed by 0.5, that means power will also reduce by 0.5. So power will be also half, that is 50 by 225 kilowatt. So first case it is simple. Because torque is becoming fixed here because Ia is fixed and you are fixing this one. So torque is fixed. If it is reduced half, then power is T into omega. So now in the second case, now what is torque here? Again power is equal to torque into omega. But now here torque is proportional to phi into Ia. Ia is fixed. But phi is not fixed here because you are controlling using field control. So obviously you will be changing field. So this is not fixed now. Okay. And E is directly proportional to phi into N. That is EB if I say. So generally what we take EB is equivalent to your VA, that is V, supply voltage. So EB1 by EB2, if you write EB1 by EB2 is equal to phi 1 N1 by phi 2 N2. So here these will be almost equal. Why? Because almost equal because your supply voltage is not changed. You have not changed V1 V2, so it is almost equal. So that's what we will take it as equal. This is an approximation. This we will do in lots of time. We will do this approximation. This back EMF is equal to supply voltage because the variation is very small. So if this is okay, that means, and now you can find just therefore phi 1 by phi 2 will be equal to N2 by N1 because this is 1 now. This divided by this will give you 1. They are almost equal. Same voltage you have applied. These two are almost equal and V1 and V2 are equal, same. So now you what is your N2? N2 is 1.5 times of N1 divided by N1. So you know now phi 1 by phi 2 is equal to 1.5. So you can apply here T1 by T2 is equal to phi 1 by phi 2. So therefore T1 by T2 is also equal to 1.5. So you apply here now. Therefore suppose this was your original power P1 W1. Now P2 will be equal to T2 omega 2. What is T2? T2 is T1 by 1.5. What is omega 2? 1.5 times of omega 1. So you will get it is the same power that you will get. The original power that is 50. Now the power is also 50. So it is 25, 1 and 50. So that means your option B. Now if you come to question number 27, in relation to DC machine, match the following and choose the correct combination. So armature EMF, that is back EMF. So you know back EMF is proportional to phi into N. So it will be phi into omega. Omega means speed, N is also speed, that is RPM, and it is radian per second. So obviously A will be connected with 2. Okay, next developed torque. So torque is directly proportional to phi into Ia. So that is phi into Ia, that means B will be with 3. So 2, 3 you already got 2, 3. So that means it is option D, you can directly say. Or you check, you develop power. Power is torque into omega. Torque is phi into Ia. So phi Ia omega. So that is 1. Phi omega, that is speed, and Ia. So that means 1. So C will be connected to 1. So it is 2, 3, 1. Now if you come to 28, in a DC machine, which of the following statement is true? The compensating winding is used to neutralizing the armature reaction. This is correct. Compensating winding is done, that is in series with the armature reaction. It is placed in the pole shoes so that it will produce the same magnetic flux like the armature is producing, but in opposite direction the connection is given so that they oppose each other, so that they cancel each other. So armature reaction can be nullified. While interpole is used for producing residual, no, this is not is used for producing residual flux. Residual flux means to have minimum magnetization, so that next time you start, it should not start from 0. So that is not done by interpole. Interpole is done to improve the commutation, because in this magnetic M&A axis, that should be the brushes should be in the M&A axis, so that the commutation can be done in 0 voltage. So to improve the commutation, that is done interpole, compensating and winding for neutralizing the armature reaction, and interpole is for improving that commutation. So that means that is your option B is the correct option or the proper answer for this question. A 220 volt DC machine supplies a 20 ampere at 200 volt as generator. The armature resistance is this much. The machine is now operated as the motor at the same terminal voltage and the current, but with the flux increased by 10%, the ratio of the motor speed to generator speed. Now here you can relate your Eb and V, because I have told you generally we take Eb and V are equal, but if it is given, armature resistance is given, then you can find this Eb and V. What is your Eb1 if it is connected in generator? Initially it was connected in generator, so generator case it will be V plus, because it is generating, so it is supplying power like this. So this is your V, so V plus this drop, or this minus this drop equal to this, because this will be higher, this will be smaller, because it is delivering power to this side. So V will be smaller, so V plus this drop is equal to this one. V is 200 plus this drop 20 into 0.2. So this was your Eb1 in case of generator. Eb2 in case of motor, it is just reciprocal. Now the power is feeding from this side, so this will be smaller, so V minus this will be equal to this one. So 200 minus, and now it is with the same terminal voltage and current, so it is drawing same voltage, that is 200, same terminal voltage 200, and current is same 20. Now it is drawing 20, earlier it was delivering 20, so it is now 196 volt. So once you know this one, then there is a relation between Eb1 and Eb2. What is? Because Eb is directly, brake EMF is directly proportional to your phi1 N1, so phi2 N2. So you can apply this one, because you know Eb2, you know Eb1, both this case. Phi1, they have said that in second case it is increased by 10%, that is 1.1, 110%. So it is 1.1 phi1 into N1 by N2, that you need to find. So if you calculate from here, your N1 by N2 will be equal to 204 by 196 into 1.1. So that is equal to 0.87, which is option A. So in this case, where RA is given, you need to find Eb and Eb1, Eb2. Don't take it as V1, V2. That will not give you exact answer. But if RA is not given, generally we approximate this Eb1, Eb2 equal to V1 by V2. Now if you come to 30, in DC motor which can be provide 0 volt speed regulation at a full load without any controller. Okay, you are not supposed to connect any extra things, that is controller, and you need to find the 0 speed regulation. Okay, so with full load, okay, load is increasing means IA is increasing. If you increase your load, that is torque is increasing, that is IA will increase. So you need to find the relation between this. So what is the speed relation? This is the relation of speed, that is N equal to Eb, that is V minus IARA in case of motor, divided by 5. So this is the way we can regulate your speed, either this or this, of changing phi, either all these options. Now if you draw this relation between speed and I for these different motors, you will find for series motor, suppose. So for series motor, if you are changing IA, if you are increasing IA, that means it is something numerator by denominator. Okay, numerator by denominator. If you increase IA, that means numerator will also decrease, because if you increase IA, this V minus this will fall down, because you will be deducting more and more, so it will fall down, and you are increasing denominator. So ultimately it will decrease quite a lot, because numerator is also decreasing, you are increasing, so it is you are decreasing it from both sides. Numerator is also decreasing, so obviously it will decrease, and you are increasing denominator by which you are dividing. If this increases, then also it will decrease. So it will decrease a very double sorted. It is double sorted. You are by beating it in one side also and another side also. In both sides you are beating it. So to bring it down. So it is the heaviest one. So it will look like this. Something of this format. Because it will come down drastically with the IE increase. Next, if you go, so you can say it is not 0 voltage regulation. 0 voltage regulation means from no load to full load, the change should be very small. So that is zero change. That is the no load to full load. This one for series. Similarly, if you count for now shunt one and again numerator by denominator. Now in shunt, if you change your Ia, then this is decreased, denominator is not decreasing. So it is just like a linear proportion. You are changing this one, then it is reducing. It is linear if you put x and y. So it is a simple straight line equation. Y is equal to some slope into x, so it will decrease. So it will be of this fashion, of a straight line fashion. So this is of shunt, this one of series. Now if you come to the third one, that is cumulative compound. Okay, what is there in cumulative compound? I have to do something then here, because it is cumulative, so sum. Now if you reduce this one, if you increase your Ia, so it will be reducing, and if you increase, this will be increasing. Now again it is double sorted, but a little less comparison, because denominator is not directly changing. If you are changing this one, this summation is changing. So earlier it was changing from 2 to 3. Now it is suppose 2 plus 2. So we are changing from 2 plus 3 now. So from 4 to it is going 5. How much change? 25% increase. 1 out of 4 it is increased. And here from 2 to 3 it is 50% increase, because earlier it was 2, now we are going to 3. So 1 out of 2. So here increase is more, here increase is little less, because you will be adding that one, then that will be increased. Directly it is not increased, it is mixed with another element. Hence it is mixed with a fixed value, because this is fixed, because this is shunt part, this will not change with Ia. So now this change will be little less, but again it is double sorted. So like your series, but not will be extreme as series. So it will be something. And series, you know, if you put Ia is equal to 0, Ia is equal to 0 in case of series, because denominator will be 5 will be here 0. So something 0, that's why it was going infinity. But it will here it will not go to infinity. It can start from some value, because if you make it 0, then also you will get some value. But in series, if you make your Ia 0, that means phi 0, so it will be infinite. So that's why it started from infinite. That's why, you know, series motor cannot be started at no load, because it will give infinitely high speed. So this is your cumulatively compound. And the last one, fourth one. So none of these are giving you zero regulation. So obviously the last one will be the answer. But still we will do this one, V minus IARA divided by now phi SH minus phi SC. Now it is differentially. So if you increase this one now, Ia, so it will reduce. Now if you increase this one, you see it is also reducing. So ultimate effect, there will be very less effect here, because if you numerator is also decreasing, means you are decreasing this one. You are decreasing denominator, means you are increasing this one. So ultimately it will be, they will cancel it out, they will nullify each other, and it will remain almost equal, constant. You can get it now. You are reducing numerator, that means your speed is reducing, but you are reducing denominator, that means your speed is increasing. So ultimately they will cancel, these two will give an effect which will almost keep it as constant as possible. So that's why it will be of this fashion. So that is known as differentially compound. So you can see the speed change here from 0 to full load. Suppose the full load is here, this is very, if I keep my full load here, so 0 voltage regulation. So this is possible if I provide full load is here. So the machine which can provide 0 voltage regulation, that is without using any controller, obviously, that is differential. Inherently it is of this property. That's why that is option D. If you like the video, then press the like button and please give your valuable comments in the comment section.